Hey guys, welcome to Chapter 1B problem set. I'm going to try and do this in a couple of different screencasts so it's not so brutal watching me do the problems. So for 28A, it says a cube of osmium, metal, 1.500 centimeters on the side, has a mass of 76.31 grams at 25 degrees Celsius. What's the density in grams per cubic centimeter? Okay, well, there's a couple of things that we have to do here. We have to make sure that we understand what is the mass, what is the volume, so that we can divide the two to get the density. Now remember, density, here we go, density equals mass, excuse me, divided by volume. And we know that density for a cube, volume for a cube equals whatever the side is cubed. So let's take a look at that first. Let's take a look at my length that I have for 1.500 centimeters. And if I cube that like this, what I get then is 3.375 and then cubic centimeters. That's our volume. So that's what will go on the bottom right here for our equation. So the other part of this then says 76.3, so density equals, and then the mass is 76.31 grams divided by our 3.375 cubic centimeters. Okay? Whatever that equals is going to be the answer to our problem, and that answer will be in grams per cubic centimeter. All right, so go ahead, I'll be looking for that answer in your problem set. So please follow along and do the math and finish the problem. Notice that lots of times it will say something like at 25 degrees Celsius, and because it's a number, it makes you believe that it's actually important to this problem, but it's not. So we don't need to pay attention to the temperature. There will be problems we'll need to pay attention to temperature, but not these problems, not the density problems. So let's take a look at the density of a titanium metal is 4.51 grams per cubic centimeter at 25 degrees Celsius. What mass of titanium displaces 65.8 milliliters? Okay, now we have milliliters instead of cubic centimeters, but if you remember, 1 milliliter equals 1 cubic centimeter. I believe that was from the 1.3, 1.4 screencast. So these two are equal to each other, so we don't have to worry about that. Again, temperature is not important, so I can ignore them, get rid of the information that's not important. I'm going to move this page up a little bit. Now, the density of the titanium metal is 4.1, so here I have density. Have you guys ever seen, the density triangle? Density triangle works like this. If I put mass on top, because mass over volume equals density, then I put density and volume on the bottom. I do this so that if I'm looking for either mass, volume, or density, I can block it out, and that will tell me what the equation is. And here's what I mean by that. In this equation, or this problem here, I'm looking for mass. So mass is the one I'm looking for, so I color out mass like this, and notice that I have density and volume right next to each other, so density times volume equals mass. So mass equals density times volume. Now, we have to make sure that our units are good. Our units are centimeters cubed for the density, grams per centimeter cubed, and milliliters for the volume, and those two are okay because they're equal to each other. Otherwise, we would have to switch them and convert from one to the other. So here I have, when I do the problem, 4.51 grams per cubic centimeter, which is the same thing as milliliters, times, and then 65.8 milliliters, like that. And all I have to do then is multiply those two numbers. Now, 1.5, 1.6 did deal with some significant figures. I'm going to get into significant figures when I see you in class, or you can watch the 1.5, 1.6 screencast and I'll explain significant figures. Significant figures is all about those digits in a measurement that are measured. Okay, if it's not a zero, then they are measured. So there are 3 significant figures in this problem, in this in this measurement, and there are 3 here. And when we multiply or divide, we go with the lowest number of significant figures, which means it will be 3 significant figures because both of them are the same, which is 3 significant figures. So 4.51 times 65.8 equals this number here, 296.758. This is off of the calculator. Notice my centimeters cubed and milliliters, they will cancel because this one's on the bottom, this one here is on the bottom, and this one's on the top, which means that I'm left alone in just grams. If I count 1, 2, 3, and I check here to see if it's 5 or higher, then I have to round this guy up. So my answer for this then would be 297 grams. And that is our final answer, rounded off to the correct number of significant figures. Okay, I think we got one more in 28, and then I'm going to end this screencast so that you guys, we can go through one problem at a time. So density of benzene is 15 degrees Celsius. Again, not important for density, but 0.8787 grams per milliliter is important. Calculate the mass of 0.1500 liters of benzene at this temperature. So the first thing I'm going to do is change my volume from 0.1500 liters, and I'm going to move that to milliliters so that milliliters my density and milliliters my volume are the same. So the way that I do that, if you remember the 0 line, which I've shown you before, where we have meters, liters, and grams at the ones place, and milli is over here in the thousandths place, to go from liters to milliliters, I go 1, 2, 3 places to the right. My number goes 1, 2, 3 places to the right, and what I have, then is my new volume of 150.0 milliliters. Yes, you must keep the 0.0 in because this decimal point means that it's significant, so you must actually show that. So now we just do our density problem. What's the density of, this is mass divided by volume, and we're not looking for density, we're looking for the mass, which means I'm looking for this again, and if we have our density triangle with mass on top always, and density and volume, and I black that out, or red that out, whatever, I get density times volume. So here again we have density times volume, so mass equals density times volume. My density is 0.8787 grams per milliliter, like that, and my volume is 150 milliliters, like that. And when I multiply the two, 8787 times 150.0, what I get then is 131.805. Here I have 4 significant figures. This 0 does not count, but the 8787 does count. And here I have 4 also, because all of these, because of the decimal point, because of that decimal point, all 4, including the 2 zeros, do count. So I count 2, 3, 4, and if that's 5 or higher, which it's not, so that means I have 131.8 grams as the answer. Okay, that is technically the answer. Okay, and that's it for this screencast.